This video presents a very basic introduction to the idea of indirect measurement, which of course can be done in lots of different ways, but in this case we're using similar triangles. And we'll introduce that topic if you aren't familiar with it. So the basic idea is this. When I look at some object, maybe like this tree here, it's hard to tell how tall a tree is, and it's difficult to measure it. But it turns out that with some mathematical approaches, we can find ways to measure this tree easily, but not directly. What we'll end up doing is actually measuring the length of its shadow and then comparing it to the length of the shadow of something else. So this drawing is going to be a little bit difficult to work with, so I want to look at a different tree right here, and I want you to imagine this tree having a height that we don't know, and it creates a shadow that is 12 feet long. Well, if I know something else is creating a shadow at the same time, then if I draw a triangle for it, pardon my drawing of a man there, now I'll be able to work with this, and here's why. If these two pictures were taken at the same time, then the two triangles are basically a scale model of each other. Okay? So if I know, for instance, suppose that this height here, excuse me, that this length was actually 3, okay? I notice that the height of the man is exactly twice the length of his shadow, and so we could tell that the tree must be 24 feet tall because it's twice the length of the shadow if it's at the same time of day. What we notice is that these two triangles, if it's the same time of day, are called similar, which means they're the same shape but different size. A nice way to look at that would be to say, you know what, the ratio of any pair of corresponding sides is always equal. What do I mean? Well, the shadow length here corresponds to the shadow length there, and the height here corresponds to the height there. So the ratio of these two would be, say, 6 to h. That ratio would have to equal 3 to 12. And it turns out if I solve this, 6 times 12 is 72, divided by 3 actually is 24. Well, as we pointed out, we made this a little simpler by making the shadow length 3, but I don't think that'll be too much of a problem. We know that the ratio of corresponding sides, 2.5 to 12, would also have to equal 6 to h, and so we can solve that. Or if you prefer, you could write h over 6 equals 12 over 2.5. What's important there is that whatever order you choose to write one ratio in, you have to write the other. Since I went small triangle to big triangle here, I have to go small triangle to big triangle there. Over here, since I used big triangle to small triangle, I have to use big to small over there. Either way, when you solve it, you're going to get the same answer. So when you look at any of these height questions with a shadow, you'll simply imagine a triangle, if it's not drawn for you, and write a ratio of their heights and compare it. Let me show you another problem. A tall building casts a shadow that's 75 feet long. At the same time, a flagpole that is 30 feet tall casts a 16-foot shadow. What is the height of the building? Well, if you make a rough picture of the building here and a rough picture of the flagpole, okay, and draw in shadows. Okay. If it's the same time of day, then these triangles would be similar. Okay. So let me write in the information here. 75-foot shadow, okay, a 30-foot flagpole, and a 16-foot shadow. Okay. If these triangles are similar, then I can write ratios of corresponding sides and then solve for the unknown variable. So I could write h over 30, that's the height of the building over the height of the flagpole, equals 75 over 16, which is the length of the shadow over the length of the shadow. Solving for h, 30 times 75 is 2250, and that has to be the same thing as 16 times h. So dividing by 16 gets you a height of the building of about 140 feet. Well, you can also use indirect measurement to measure other things. Here's a picture of a lake in Yellowstone, and it's unwise to be swimming across lakes trying to use a measuring tape to find out how far it is across them. In fact, those people really should not even be sitting on the railing because this lake could be extremely hot, and if it's not extremely hot, it could be extremely poisonous. So if you go to Yellowstone, please be more careful than this. I want you to imagine this little lake here. I've drawn a picture. Maybe you like it, probably a little safer. And I'm going to show you how you can use indirect measurement to find the distance, say, from point A to point B safely. Well, first I'm going to draw lines. Try it again. You draw a line out to here and a line out to there. I pretty much figure I could make those measurements fairly easily. If it's a little unsafe to be measuring across here, then we could always just stretch the triangle out further. Then I'm going to just step somewhere in the middle here and create another line, and I'm going to make sure that I've been careful here to imagine, if I imagine the line here, both of these lines are at a 90-degree angle. There and there. That's important to make sure that it creates similar triangles. Well, let me label some spots here. Let me put C and D and E. And what I want to claim is that this triangle here, C, let me draw it darker, CDE, CDE is going to be similar to triangle CAB. So these two triangles are similar. Well, I'm going to just pretend that I made some measurements here. Suppose that this is 130 feet all the way across there. Okay. And this is, I don't know, how about 80? And then I'm trying to find this distance here, but maybe it's a poisonous lake or a very hot lake, and it's not safe to actually measure it. So I'm going to measure this distance right here. And perhaps it's 60. Well, now, if you imagine my two triangles, it's harder to visualize because one's inside the other. But from a big triangle, I'm looking for the vertical side, and I know the vertical side right here, and I know how long the horizontal side is. Okay? On my small triangle, I know the vertical side and the horizontal side. So now what I'll do is write a couple of ratios. The ratio of the big sides, D over 60, is going to have to be equal to the ratio of the horizontal sides, 130 over 80. So D over 60 is the ratio of the vertical sides, and 130 over 80 is the ratio of the horizontal sides. And those two ratios have to be equal if these two triangles are similar. Now, since I have a proportion, I can solve that easily. I'll multiply across 60 times 130. That gets me 7,800. Divide by 80, and that gets me D is 97.5 feet. If across the lake, but I didn't have to measure it. So there's a couple of examples of indirect measurement. Thanks.